welcome Rick Howe, Speed Invest.
Good afternoon, everyone. So I am Rick Howe. I'm principal at Speed Invest. So our team at Speed Invest, we support and invest high-impact deep tech startups in Europe. In the past 10 years, we invested more than 170 startups. Today, I'm going to introduce a very special one from our portfolio called Poro Technologies, also known as Porotech. Porotech is a spin-out from Gallium Nitride Research Center at University of Cambridge. They, based on more than 10 years research in this field, they developed a new type of gallium nitride material to change the display technologies. And recently, if you look at the news, you'll probably see one big news from Porotech. They created the first micro display based on native ride gallium nitride in the world. So this is the first time some startup can basically commercialize such a complicated process. And also, this is a big breakthrough in this area. And even more important is, normally you don't see a great scientist who is also a great CEO. And here we have exceptional one, Dr. Tong Tong, and he will explain the magic solution of Porotech. So I will pass to him to explain more about Porotech. Thank you.
Breaking the wall of inefficient microdisplays. Tong Tong Ju, Poro Technologies.
Thank you very much, Rick, for the kind introduction. Thank you very much. I remember when iPhone was launched back in the day, 2007. I do believe their initial aim was to giving everybody a better life, and it has. It has changed substantially people's lives and their lifestyles. But I also believe that the aim wasn't to encouraging people to use mobile phones all the time. So what's the fine line between the digital world and the real world? Someday, maybe the smartphone may be the thing in the past, but all of the functionalities of the smartphone might be integrated with what we wear and what we see. The so-called augmented reality is the perfect way to bridge, to allow us to connect and interact with the real world around us, along with the digital content go with it. And micro-LED display is the next major leap that promising this micro-display-based augmented reality because of the brightness, because of the efficiency and form factor, especially against the sunlight, where most, or if not all, the existing display technologies are very difficult to see clearly. And micro-LEDs, you can make micro-LEDs with different materials, with different architectures. And the problem with that mixing and match, the problem is the manufacturing process can get really complicated. And also, driving millions of pixels is going to be a headache for everybody. And on top of that, making really tiny, small micro-LEDs in order to keep and maintain a high resolution is a hard challenge in terms of maintaining the efficiency of those micro-LEDs, particularly for the red color. And because of that, full-color microdisplay with high resolution, high efficiency is far from reach and is extremely challenging to achieve. And we at Porotech, we developed a revolutionary breakthrough material technology called Porous Gallium Nitride material platform technology, where we can, based on existing materials and production solutions, where we use a wet chemistry simply to manipulate and engineer the material functionalities and properties and optimize for the end microdisplay applications. And not only we can achieve the highest efficiency in the planet on the red for microdisplay, micro-LEDs, but also we are enabling all three colors in a single wafer on a single chip. That will really revolutionize and accelerating the augmented reality applications in the years to come. And we are the world's first to provide commercially available red micro-LEDs, less than 10 microns, with high efficiency to the market. And we have recently launched the world's first native micro display with 2,000 PPIs and that contains 500,000 micro-LEDs. And that gives not only the high resolution, but also the high efficiency over just across 1.5 centimeter across the area, which can be integrated into some wearable devices and goggles like those ones you're wearing. And because the fundamental difference of our approach is that we utilize the existing production throughput, the capability, by adding one extra step that we are very good at. And we are doing the dirty works for producing the porous gallium nitrides. And we work with partners, world-leading partners along the entire supply chain, including the world #1 display company. And because of that approach, we've been quite lucky in terms of accelerating our progress. Within 18 months, we've been raising £4.5 million in the investment. We have a very small team, 20 people, but we have done the technology transfer, pilot production. We have got the supply chain in place. We're working with world-leading companies to commercialize this technology. And essentially, we're working with everybody along the value chain. And we're currently closing our big Series A round of investment to press the button to accelerate even the process to get the microdisplay products out on the market as soon as possible. Thank you very much.
Good. We're going with questions right away. Who wants to start? Well, okay, you covered it all. Yes. One here, and then also the second here in the first row. Thank you.
So maybe helping the audience a little bit, why is red so important? Because at the moment we have our micro LEDs, so it seems to work fine. Maybe you can explain a bit more what sort of value that brings and how important it is.
Yeah, thank you. So the micro LEDs, the most important thing is when the user cases are mostly in the outdoor settings, where we connect and interact with the world, especially we put our hands free. And for that particular reason, for particularly normal displays, we're talking about thousands of nits, but in the outdoor setting, we really need millions of nits. And that's where the micro LED is really promising in terms of fulfilling not only the efficiency, but also the brightness, as well as the miniaturization, or keeping those in the glasses format. So for that particular reason, the brightness, efficiency, and the economics as well, that gives us a lot of hope in terms of getting the augmented reality realization sooner.
Okay, next question here.
You showed us a red display that does red-black, right?
Yes.
Is the ultimate goal to have a full-color display, or is that a product already that you will be selling? And if so, for what applications?
So the red color is just one step that we achieved, the biggest milestone, which is the industry is lacking. And as I mentioned, we are working on putting all three colors monolithically generated in a single tool chain, in a single material, on the same wafer, on the same surface, so that everything that you will be worried about in terms of manufacturing will be eliminated, as well as the driving scheme that can be unified as well. So the RGB is something that we will be pushing aggressively on developing, but actually we have already achieved multicolors on the same surface from the single pixel already. We haven't announced it quite yet, but that is a product available that we're working with industry partners to commercialize and putting into a real prototype as well. Probably later this year, we will be announcing a multicolor from the same surface, from the same pixel. Thank you.
Okay, we have a next question here. Thank you.
Thank you for the exciting talk. Assuming that you will master all the technological hurdles which are on the way, does the micro-LED technology has a full potential to fully replace OLED technology in all areas in the future?
Yes, of course. Why? Because we're talking about display, microdisplay. We're not just talking for a display format. We're talking about the pixels that contains the ability on demand wherever you want to display the information, but also because we're miniaturizing the chips into a very small space, we can also integrate other functionalities. And that's how porosity can introduce other functionalities as well, like piezoelectricity, sensing capabilities. Essentially, you can interact as well as seeing what's in front of you in the future. In a way, a single pixel is a display.
Okay, next question. We would have time for one last small question. Here we go. Thank you, third row.
What would be the concrete first application for this new technology?
To be honest, there are two major applications coming up. So some people that are making big TV outdoor signage using small micro LEDs because of the economics that you can get around with the yield issue. Because you miniaturizing making micro LEDs smaller, then you don't see that. You don't need that 9949 in terms of yield. But in the same time, that also other people were working on augmented reality glasses. You might have seen some technology companies coming up with some solutions or prototypes or pipeline products. But hopefully with our product, that will be quite speeding up the whole process and the product commercialization of the augmented reality glasses, which I believe will be the first winner, because we really need to free up our hands. I don't want to use my mobile phones all the time.
Okay, good. Thank you very much.
Thank you very much indeed. Thank you.